Okay, so we'll get started in about 2 minutes. For those of you who haven't, log in, have a go at the question on the board. Just a note from last week, there was a bit of confusion about between. I've clarified it, I think, in the announcement I made on Moodle, as well as on the board here. So if you say, for example, where Z is between X and Y, that's inclusive, so that includes X and Y. So if we said, is Z between 5 and 7, that means, is Z 5, 6, or 7? So, or within 5 to 7, inclusive. That should help you answer the question on the board. As I was saying, there's 3 correct answers to the question on the board, and only 1 incorrect answer. So we'll give you 1 more minute on that, and then we'll get started. Okay, 5 more seconds to get your answers in, then we'll get started. I heard you counting it. You had such like a professional attitude up until you wanted to submit your answers. All right, just for you, I'll give you an extra 15 seconds, all right? You done? Okay, good. Okay, so the correct answers were B, C, and D. Okay, guys, settle down. A is not correct. Can anyone tell me why A is not correct? Sorry?
It doesn't include 1920 and 1925.
Good, it doesn't include 1920 or 1925, but the question asked you to include those. Okay? Does seem like the majority of you got the right. Some people are a bit cautious. So we did mention in last week. I know we didn't spend any time on it, but we did mention it. So you can provide a list of items. As you'll see in week 5, what you can actually do is something a lot smarter here, and you can provide another query, so you can select into an in, and these like sub-queries going down. So you'll see that in week 5. So this week then is all about joins and keys, and this is where we start looking at sort of multiple tables, joining multiple tables together, and how we access data which has a reliance on data elsewhere. This is where we are in the weeks. We're only in week 3. How's it feel? So 1 thumbs up and 1 cool, that'll do. Good. So today we're going to be looking at describing the role of these 3 database key types, calculating the result of joining SQL statements. So notice how last week we were doing non-joined statements. This week we're doing joined statements. And then the same as last week, proposing suitable joined statements. So the content for this, a bit of keys and relationships, we have some questions, SQL joins, we're then going to have a big example, and then we're going to touch on counting and limiting our SQL statements, just as a bit of a breather for you, before some more questions. Okay, so take the example table below. So this is a table containing class information for a given school, right? You've got a class ID, the name of the class, the year group they're in, a teacher ID, teacher name, a teacher email. For notational purposes, I'm going to start underlining the primary keys, okay? Just so it makes it obvious where the primary keys are in the table. But is there something inefficient about this table? Yes? I heard a yes. Who thinks there's something inefficient? Yeah? What's inefficient? Good, yeah, we're repeating the teacher's details every time the teacher occurs, yeah? So every time we're repeating this teacher ID, you're actually repeating the name and the email address as well. That takes up room, that takes up storage, and ultimately it makes our queries run slower. So what can we do about it? Anyone have a guess as to what we can do about it? Yeah?
Have 2 separate tables.
Have 2 separate tables, good. There we go. So the teacher's email and name are actually reliant on the teacher ID, as I said. So what you can do is you can strip that out into another table, and reduce the amount of repeated information to 0. Well, you are repeating information, the TID, but you need that in order to reference the teacher table. So what we've done here is we've applied our asterisk here, and now this is known as a special type of primary key, which is a foreign key. So here it's called a foreign key, which is a primary key here. So a foreign key is a column in another table which refers to the primary key of a different table. So TID here is a primary key, but over here it's a foreign key. Okay? And our foreign keys are denoted with an asterisk next to them, and you'll notice that it's underlined here because it's the primary key of this table. Does that relationship add up to everyone? Yeah, good. So a foreign key is a column in which the primary key of another table. But it's not always that simple. Take this table, for example. A list of properties, who owns it and how much they're looking to sell it for. We've got the number, the postcode, the owner's name and the value. What should we use for a primary key here? Yeah? Num? There's a problem with num, isn't there? Postcode repeats as well. What's unique? You could argue value is unique. Someone said, but it could. Owner name? Well, Laura is twice. Marcus is twice. Yeah.
Combination of number.
Good, brilliant. A combination of number and postcode. I know it's a bit of a tricky question for those who don't know how postcodes work. I had to Google it to make sure I was right here. But your number and your postcode actually makes a unique identifier for every property. So what we can do is use a combination of num and postcode. We give them an underline, and we call this a composite key. So it's a composite key because it's a key made out of multiple columns. Yeah, there are multiple columns which make up the primary key for this table. But it gets even more complicated than that. Take the following table. So we have the property table again, which has the composite key. We then have this offer table. So we have two composite keys here. Offer has a composite key here of buyer ID, num and postcode. It has two foreign keys, which refer to the property. And this is a special type of key in itself, called a compound key. So any composite key which contains within it a foreign key, we refer to as a compound key. Okay? So you can think of it like this. Inside primary keys, there are two types, composite and compound. Compound is a special type of composite key. There you go, a bit of a whiz round of keys there. It's time for some questions. So those of you with your Menti still open, give you 20 seconds on this. Which type of key is used as a reference to the primary key of another table? Oh, 2 of you straight in there, 5 of you straight in there. Lovely. Okay, let's have a look. That's incorrect, isn't it? So apologies, that's actually meant to be a foreign key. Which type of key is used? Yeah. The 21 of you are right, and Andy, who wrote this the other day, is incorrect. Why is it not composite key? Oh, silence. Yeah.
I don't know if it's like together with something.
Yeah, we don't know if it contains another foreign key, right? Good. And why isn't it primary key, despite what I said? Already a primary key, yeah, good. Okay, next then. Which of the following must contain multiple columns? So focus on the word must here. There are 2 correct answers. Give it 10 more seconds. Okay. Okay, Andy got it right this time. Composite key and compound keys, yeah? So compound key is a special type of composite. Yes?
Can a compound key contain multiple foreign keys?
Yes. Yeah. So if you had, say, 3 tables, then the table in the middle could contain foreign keys from each. Yeah, that's fine. Yeah, that's not a problem. Composite keys, as we said, the definition is they are a combination of multiple columns, and a compound key is a subtype of this, so it must contain multiple columns, irregardless of what they are, although we know that it must also contain a foreign key. Again, not primary key this time, because primary keys can just be one column, and foreign keys are just a reference to another table. Yeah, they don't necessarily have to be part of a primary key in themselves. Do we have one more? Okay, we have one more. Which of the following must contain a foreign key then? We'll give you 10-15 seconds on this. Perfect. Let's see how we did. Compound key. Okay, so here there's a bit of confusion, it looks like, between composite and compound. A compound key is a type of composite key, but that doesn't mean that all composite keys are compound keys. Compound keys must contain that relationship to another table, that foreign key. Composite keys don't need that. They could just be two columns in a table. Yeah, they don't need to be foreign keys. A reference key doesn't exist, that's not a thing. I'd argue that's probably the closest thing you have to a foreign key, but that's a term that just doesn't exist. And primary key doesn't have to contain a foreign key, same as last time. It can just be columns within the same table. Okay, so when we have multiple tables, guessing a bus just pulled in. When we have multiple tables, there's a thing we can do called joining, which is a process of combining lots of information between those tables together using the relationships that we just looked at with the keys. So take this example. It's an example we just used, the teacher and class. You've got primary key CID, a foreign key which refers to the teacher table, and then TID is the teacher's primary key. How can we write an SQL statement to extract a list of class names and their relevant teacher names? That's what joins try to solve. Or we could try this. Select name, teacher name from class teacher. Can anyone guess what will happen here?
Error.
Sorry? An error? No, you won't get an error. It's a perfectly valid SQL command. Anyone else? Anyone over this side want to have a brave guess? Combines two tables. Do you want to have a guess? No? Okay, so what happens here is we end up with this. Every class listed with every teacher. That's not particularly helpful, is it? This is what's known as a cross-join. It's something which combines all of the information in tables A and B together. So notice how there's no conditions here at all. It's just combining everything together as much as it can and giving you the answer. But that's not very useful. We want only the allocated teacher. But for illustration, let's try running this. Asterisk this time. What do we think will happen with the asterisk? Everything. What do you mean by everything? All the details? Yeah, all the columns. Good. So we end up with something that looks like this. Every class listed with every teacher. Yeah, irregardless of whether their teacher IDs match. Now I wanted to show you this because it kind of explains why the old solution I'm going to show you next uses a where clause here. How do you think we could resolve this? Does anyone have an inkling as to how we could resolve this? Yeah.
Use where clause, so where class.tid equals to teacher.tid.
Perfect. And that is exactly how people used to do this. So the call was to use a where clause to say where this TID equals this one. So the one from class equals the one from teacher. Because that's how we know how they're allocated, right? Is that they're the same. And that's exactly what they used to do. So select name, teacher name from class teacher, where class TID equals teacher TID. And that gives you, exactly as we'd expect, a list of classes with their allocated teachers. So this is what's also known as an inner join. And that brings us on to our next statement, called inner join. So you can select name, teacher name from class, but this time we use an inner join statement. Now what this says is, I want to join class to teacher, and here are the columns I want to join it on. So here's where I want the matching values. So here we've got class TID equal teacher TID, just like we saw in the where clause, only this time using the inner join. And the result is the same. So we get exactly the same result. Let's add some more data, and then let's try inner join again. Do you think anything different is going to happen this time? Down at the front? No, nothing different? Okay. How about over here? Anything different going to happen? No? Good. Nothing different happens because this class hasn't got an allocated teacher. So there is no teacher that has a matching ID because it doesn't have a teacher. But there are other types of joins that allow us to extract all of the classes and all of the information. For example, a left join. So here we got the same select, the same from, but this time we're using a left join. Can anyone guess what a left join is going to do? Yep.
Back everything on the left, regardless of if there's a match or not.
Good. Anyone disagree? So the answer was anything on the left, regardless as to whether it has something on the right. Nodding. Got some nodding there. Perfect. So it retrieves everything on the left, which in this case is the class, regardless of whether they have a teacher name. But if they do have an allocated teacher, it also retrieves that. Okay? We can do the same with a right join. Someone down at the front here. After we've just seen a left join, what's a right join going to do? What was that? Yep, good. So it's going to put everything on the right, which in this case includes the teacher called Penny, who doesn't have a class at all. But it includes that empty value for the class name. There are full joins. Someone at the back, what's a full join going to do? We just saw a left and a right and an inner. What's a full join going to do? All of it. Perfect. Yep, so we get all of it. So we get all of the ones which match, as well as the ones which don't have any allocations at all. Yeah. So it's not a very useful join, this. You'll find that you barely ever use this one, but it's good to know about it. So a big example then. So here we have 4 tables. We have the teacher and class, just like we've seen throughout the lecture. We've then got a student table, which has a student ID, and then this registration table, which contains student ID and class ID, and which students are allocated to which class. So there's one composite key. Where's the composite key here? Sorry? Registration. How about the compound key? Someone at the back over there? Where's the compound key? Anyone? Yep. Class? Not quite. So this is a composite key. What else? Yeah? TID? No, that's a foreign key. The compound key. CID? No. What table contains the compound key? Reg. Yeah, good. So it's a composite key and a compound key. Yeah? Because compound is a subtype of composite. Yeah? So it's a composite key at the high level, but it's also a compound key because it contains those foreign keys. So you were right when you mentioned the foreign keys, as I think many of you were suggesting, the CID and SID. But because they're part of a composite key, that makes them a compound key. Okay? So we can see how students are registered to classes, and classes have an allocated teacher. So there's 3 relationships here. And let's have a look at how we can retrieve some names of students in the class herons. So, simple one to start with. Select student.name from student. What do you think the first line of this is coming up? So we're selecting the student name from student. Great, so we're going to get a list of names. What's the next line? Where? It could be where. Join, yeah, good. So we got in a join, yeah? So if you're doing it the old way, where would be correct. But we want to do it the new way because it's much more efficient. So we do an inner join reg on reg.sid equals student ID. So that follows that relationship between those 2 tables by linking the primary key here with the compound key here. Okay, so now we've connected those tables together. What are we going to do next? Sorry? Class, connect class, how are we going to do that? Yep.
Reg.cid equal to class.cid.
Yeah, good, so we do another inner join. Where we do reg.cid is class.cid. We do an inner join because we only want the ones that match. Yeah, we don't care about the rest. They're irrelevant to our question. And then we add this where clause on the end where class name is herons. Because we only want the students where the class is herons. Run this and you get Hannah and Omar here who are SID 0 and 1. 0 and 1 are both allocated to 0. And 0 is class herons. Okay? Any questions on that example? No? Good. Number 2 then, retrieve the student name of all students taught by Lewis. So again, we have select student.name from student. What's going to be our first line here? In a join, good. Student. Next one? inner join again, and the third one. Another inner join, good. So we're going to inner join to teacher, add the where clause on the end for teacher name, and you can see how the three relationships link the tables to give you Katie and Alex. It just so happened that those two were separate in the example. Good. So, counting and limiting then. So we've just seen how we can join lots of tables together using the composite and compound keys. But in DML you can also perform a couple of sort of high-level operations that allow you to retrieve sort of content or metadata without actually having to retrieve all the data from the database. So we can limit the amount of data you retrieve. For example, you can retrieve just 5 rows at a time, or oftentimes you only want to retrieve 1 row at a time. But you can also count the number of rows that you'll be retrieving instead of actually retrieving the data itself. So an example of counting the number of students, select count star. So we have select, I want to count everything from student. And by count everything, what this means is count the number of rows here. So in this case, what do we think it will return? 4, brilliant. So it's going to return 4. If we had a where clause on the end that said where SID greater than 1, 2, 20. Oh, yeah, 2. We can also limit to only 2 rows. So in this example, we're selecting all from student, limit 2. What will be returned from student? The first 2, yeah. It's not going to be picky. It's only going to give you the first 2 items from that list. Perfect. So we're a bit ahead of ourselves here. So let's have some questions. So here we got the 4 tables we saw before. So student, reg, teacher, class. So an SQL done at the bottom. Can you guys at the back see that, okay? Yeah? How many rows are returned from the following SQL query? So here we have a select star from student, inner join reg on reg.sid equals student ID, inner join class on class cid.reg equal to reg.cid. So have a go at that. I'll give you 30 seconds on this one. Oh, we've got a mix of results so far. Give you a little longer on this. Forming a normal distribution. I don't think it's meant to form a normal distribution. The problem is I haven't actually written down the answer. So it's going to be a surprise to us all. Okay, so I'm going to show the correct answer then. 4. So most of you got it right, even if it wasn't a complete plurality. So why is it 4 then? So we have select all from student. We have 5 students. Inner join reg on reg.student ID. Only 4 students have registrations. Yeah. So because it's an inner join, you're only going to get 4 of the 5 students at least. Okay. How could we answer this without selecting all? Anyone want to be brave? So instead, select all. Yeah, good. We could use a count. So instead of this, you could go. Don't know how black's not going to work on black, is it? You could try count asterisk. It's probably worth mentioning you don't have to count asterisk. You can count other fields as well. So if you wanted to count, for example, student ID, you could count student ID like that. So you can count individual columns instead. Largely, it's the same until you start grouping things that we'll see a little later on. Probably next week or in week 5. Okay, any more questions on this example? Does it make sense as to why we got to 4? Good. Let's have a look at the next question then. So this time it's the same, but how many columns are returned? I promise this isn't a trick question. We'll give you a minute on this. Well, 3 and 9, okay. Someone's brave with a 7, I like it. A 2. At least we're not making the normal distribution this time. It's kind of a bimodal distribution, maybe. We have 15 more seconds. Okay, let's have a look at the answer then. So 9 is the correct answer. Only one of you, who was the lucky person? Sorry, I'm not going to embarrass you. 9. So a lot of you said 3 or 7. I'm guessing those of you that said 3 refer to the student table with only 3 columns. Would that be fair to say? Unfortunately, we've got these joins here. Now, if we go back to very far back, here, what happens is we get all of this. Yeah, so that's without the inner join. When we join things together, we added some data here. Do I give an example? I don't give an example. So you get name and teacher ID. But if you look at, if we look at this, imagine an inner join in here where we're only retrieving the ones which match. Does that change the number of columns we should have? So if I added an inner join, instead of this, if I said inner join teacher, should the number of columns change? No. I saw a shake of the head there, that's enough for me. No. And that's because we're still essentially doing this process and then filtering down. So you're still getting all of the columns and then jumping back to filter out the number of rows afterwards. So here we go. So we have student, which contains 3 columns. Yeah, sorry, question.
It would depend on the dialect of SQL you're using, because sometimes you only get, if you're joining by SID, for example, you only get one SID and the matching register. You only get 1 column.
Not in SQLite you don't. So, yeah, we'll do that now. So we'll go through. So student contains 3 columns. We're then joining on reg, which contains 2 columns, but technically those 2 columns are different because SID and student will be a different, stored somewhere else, somewhere completely different to the SID and reg. So you technically add both to your column count. When you do this, this probably isn't very useful to you, so you'd only select the columns you're interested in. If you only wanted the student SID, you'd say student.sid. So we connect reg, and then we connect class. So because we're connecting class and we haven't filtered on any columns, we add the 4 remaining columns to 9. Yes?
How do we formulate a table on which there is no duplicate column? So I guess SID will be both and will be twice.
Don't use asterisk. You'd have to label the columns manually. So you'd say something like student.sid, comma name, whatever other columns you're interested in. Okay. Any other questions here? I just saw another 7 pop up. I hate to tell you that's wrong. Okay, so what if we change this then? We'll change the question slightly to be select star from student. I'll bring this up and we'll add another inner join on the bottom. I hope this isn't my next question actually. No, it's not. Good. So we're going to go inner join. What other table we got? Teacher. On teacher.tid equal to class.tid. Give you 30 seconds to think about that one. Okay, anyone brave enough to give it a shot? 6. Not quite. Up. 11? 9, 10, 11. Good, yeah, perfect, 11. That's because what we've done this time is we've taken exactly the same query, which contains 9. And then all we've done is append the teacher table onto the end of it, right? So we have 11. Okay. Does that make sense? Yeah? Feel free to say no. You can say no if you want, it's fine. Okay, let's go for another question then. Here's a fill in the blank one. How many rows? Fill in the blank, not how many rows. I don't know why. Stupid question. Now I've got to figure out what the question was I was meant to ask. Unit group is 2. Oh, that's it. Can anyone guess what the question is if I show you the answer? That's how we'll do this. What's the question? So if this is in a join, what's this query answer? You all are. Yeah. What's this query answering? Yeah.
Probably something which returns to the class.
Not quite. Yes.
We give the one with pigeons, the class with pigeons, and the name will be.
Almost. Yes. Good. So it's asking you to retrieve the name of all students in the second year group, right? That's the way to fix a broken question, isn't it? What would happen if this wasn't in a join and this was something like, let's go over left join? What would happen there?
You would get the same result.
Why would you get the same result?
Because you're filtering on the result of the join, not on the condition.
Yeah, perfect. Yeah, so if this is a left join, you get exactly the same, so it doesn't change the student names at all. Right, did you guys vote on this? You need to vote on this one. Okay, now this is a more reasonable question. We'll give you a minute on this. How many rows will be returned from the following SQL query? We've got to select asterisk from class, but we're joining teacher with a left join. All right, let's take a look. 6. So why is it 6? So we're looking at the number of rows that are returned from this statement. Selecting everything from class, left join teacher. What does the left join do? Yep. I like the visual interpretation, but I kind of need that. Yeah, good. So you take everything from the left and try to join as much as you can from the right. That's a good way of putting it. I like that. I'm stealing that for next time. So we get a left join on teacher and get the class ID, but we've got 6 classes. One of them hasn't got a teacher. We don't care. What if I change this to an inner join? Someone down at the front. 5. Perfect. Why 5? Yeah, perfect. One of them hasn't got an allocated teacher, so only 5 will be returned. How about right join? If I change that to right. 5? Just double check.
6 as well, but without the information in the class, from the class table that's not matching.
Yeah, so it'll be 6, but the class information will be null. That's good, yeah. So if we change this to a right join, what we actually do is we retrieve the 5 here, but do have teachers allocated. We don't retrieve this one. But we also retrieve a hidden set of information from teacher, which in this case is the teacher Penny that isn't allocated to a class. So you technically get 2 Penny here. I don't know if I can write. But all of this is null, because she isn't allocated to anything. So you do end up with that null row of just emptiness. But you do get 6 rows technically. Perfect. Oh, way ahead of time today. Okay, what will be returned from the following SQL statement? Or how many rows will be returned from the following SQL? Oh no, it is correct this time. What will be returned from the following SQL statement? So we're selecting a count of everything from class, left join teacher on teacher.tid equals class.tid. So same statement as before, but with a count, and we've got this limit 1 here. So it's a bit tricksy. Give you 1 minute on this. The answer is not obvious. I'll give you that hint. I really love how you all make sort of normal distributions in this. Like, regardless of the question, there's always a normal distribution somewhere. Or there's a bit more of an extreme value distribution. Okay, let's have a look. So the majority say 1, a few of you are saying 6 and 2. The answer is 6. Okay. Why is it 6? Why is it 6? So we have exactly the same query, right, at the start. Select something from class, left join teacher. That gives us all 6 of these rows. Yeah, happy with that bit. We're counting them. So we're counting to 6. And what happens is, limit applies after everything's been executed. So you count to 6, then apply your limit. This is only 1 row. So it's only going to return that 1 row. Okay. Does that make sense? So I think what a lot of you did is you applied the limit before you did the count. What it actually does is the other way around. You apply the count, then the limit. Okay. Bit of a tricky question. Bit of a tricksy question. Yep.
So if we wanted to implement the limit, where would we put it in pairs, for example?
If you wanted to limit how much you're counting.
Yeah.
Stupid idea.
Yeah. Right.
I'm not too sure. I don't think that's ever come up. Look into that and let me know next week. Because why would you want to limit when you're counting? Because the whole point of a count is to count. Interesting question though. So if we change this back to an inner join, like we said in the last question, what will happen? 30 seconds and then we'll shout out some answers. Okay. Guys at the back, what do you think? 5? Okay. Guys at the front? 5. This side? 5 at the back? Not a clue? Not a clue. Anyone else over there? 5. Okay, so we're all not normal distributing this time. We all said 5. And yeah, it would be 5. So if we change this to an inner join, what we're saying is that we want all of the classes that have a relevant teacher, right? So only the ones which have a TID, and we're counting them, same as last time. So 5, limiting 1, our count of 5 is the only row that we have. So we return 5. What would happen if we took out the count? Let's take out the count here. Keep the asterisk. Let's go limit 10. Why not? How many rows would be returned here? Keep the left join. What was that? 5? It's left join. 6, yeah, good, yeah. If it was inner join, you'd be right, yeah. 5. So 6 this time because I've gone back to the left join, limit 10, we're under the limit, so it doesn't matter. It's not going to pad out the rest of that data. Okay. Last thing I want to show you is how we create a table with a foreign key. I'm going to have to keep this up, aren't I? Do I have an empty slide for this? We'll do that in a sec. That'll do. Okay, so last week we looked at creating tables, right? Can anyone remember the structure for creating a table? Create, good, yeah. Create, table, good. As, who said as? No, table name. I'm going to call it test, why not? Open bracket. And this is where we put all of our columns, right? So in this test table, let's have some sort of ID. I'm going to make that an integer. We're going to look at some more types of these in a couple of weeks' time in week 5. Let's add something else. Let's add a name. What sort of variable should contain a name? Varchar, good. What's a reasonable size for a name? 10. Is it 10? 20, 50, yeah. Go 50. It's always better to be generous. We're not exactly strapped for size these days. How do we set up the primary key? Anyone remember that? Primary key. Sorry? Capital primary key, good. Primary key. Bracket. Whatever the primary key is, right? So in this case, we'll just use ID. We'll assume it's that. There we go, nice and easy. So that's how we set up a standard table. Now let's add in here, let's say TID. Assume we're talking about teachers again. We're going to call it an int. How do we make that a foreign key? Assume somewhere else that we've got a table called teacher. We've got this table teacher somewhere that has a TID. How could we set up a foreign key? Can anyone guess? Secondary key? Not quite. Foreign key, good. So we can literally type foreign key. This is why I'm going to spell foreign wrong. Foreign key. And then you simply put whatever key is foreign in it. So in this case it's TID. And if I'm right, you have to put comma at the table, but sometimes the notation will vary depending on which implementation of SQLite you're using. But for the sake of this, we'll do the teacher. So you tell it which table it's referring to, and we'll talk about constraints like that more in a couple of weeks' time. If you wanted to have a primary key that's also a composite key, what would you do? Let's say I want my primary key to consist of ID and TID. What could I do? It's not a trick question. Yeah, perfect. You can put both in here. So if we wanted them both to be part of our primary key, we could just put comma TID. But that's not just a composite key, is it? What is that? Compound key. Hey, we did it. Perfect. So that's how you set up tables like that. I don't think you need to know that for your assignment, but it's always good to know anyway, in case something goes wrong. Perfect. So do we have any more questions? No? Feedback time. So based on this lecture, so far, how comfortable do you feel joining tables, describing the 3 keys, and proposing certain SQL types? Again, this doesn't hurt my feelings. Maybe slightly if you all said 0. And it's always nice to see you not form a normal distribution, so there is that. Perfect. Okay then guys, thank you very much this week. There are exercises on Moodle again, as well as a walkthrough of the code from the lecture. Any questions, feel free to find me in my office hours, but if not, enjoy the labs.